My name is Marcus, and I'm the member of Group 1. Today, my talk will be divided into two parts. First, on behalf of my team, I would like to give an overall introduction of our project. After that, I will give an introduction to the part of the project that I'm responsible for. Now let's start. The name of the product we designed is called Portable Heartbeat Monitor. And the introduction of this product will mainly be expanded from following four parts. Okay, let's start with the first part, abstract. Our idea of designing this product comes from the design to design a device that people can use daily and portable through some basic components such as micro:bit, speaker. We use some hand-wheel knowledge and some basic programming knowledge that we learned from this course to turn our vision into reality. What we developed is a portable heartbeat monitor that can provide users with real-time heartbeat detection, comprehensive data, and display heartbeat data and image to users according to their needs. Our device is composed of 3 micro:bit, 1 OLED, 1 heartbeat sensor, some wires, power supply, and a speaker. There are 4 functions be contained in this device. They are recording data, analyzing data, drawing images, and detecting data. From this diagram, you can see that as our main control board, M1 can obtain heartbeat data and use the instructions in real time and send this information to other devices via Bluetooth. And the storage and analysis module, M2, is used to store information from M1 and display this information on the OLED or perform statistical calculations on the data according to the user's instructions. As an analysis module, M3 will retain up to 7 sets of data from M2 through the calculation principle of normal distribution. The speaker will alert the user when abnormal data is obtained. Next, I will talk about the second part of the introduction. In this part, my team member and I will give you a detailed introduction to the part of the device that we are responsible for. The first part, which I'm responsible for, is the monitor. The function is mainly composed of 2 components. They are M3, micro:bit, and speaker. In terms of algorithm, in order to analyze the obtained heartbeat data, we have introduced the normal distribution rules to distinguish whether the data is normal or not. The purpose of this function is to analyze the heartbeat data and alarm the user when abnormal data is obtained. This is the code display of this monitor. We use following simple and practical programming options to achieve it, and this is a physical demonstration of it. The idea of this feature is for the purpose of enriching the practical of the device by adding a speaker to promptly alarm when the user's heartbeat is abnormal to remind the user of the health schedule of the user body. Okay, let's move to the second part.
Thank you, Mr. Ma. Firstly, let me introduce myself. My name is Duan Weilun, and I am the team leader of Group 1. I will concentrate on 2 features I'm responsible for. They are recording and retrieving data and drawing my charts. Firstly, for the first feature, I use micro:bit 1 and micro:bit 2 OLED and Bluetooth to record and retrieve data. The main algorithms used for this feature are get number and the screen live feed page function. Get number is used to give the user feedback on starting and ending number, and the micro:bit displays the corresponding interval of the data. Screen live feed page function is used to display data. When there is a lot of data, the OLED can't wrap itself, and this causes some data to be lost. So I wrote this algorithm to show more data, whether there is hundreds or thousands of data. This is the procedure chart. Okay, now let me show you the demonstration with this procedure chart. As you can see, firstly, I press the button A in micro:bit 1, and it will ask us, we have key data from which to which you want, and it will send the 0 to microbit 2. And then I will press button A in microbit 2 to input the tens and the ones of the number to microbit 2. And it will send this message to microbit 1. Microbit 1 will show your data, will show your number, and then show your data you want. After briefly demonstration, let's look at the code. As you can see, this is asking part, and then it calls get number function and send a message to microbit 2 and get a number. Then it shows a message to microbit 1 and we will get the data we want. This is the first feature. Very perfect. Now let's talk about another perfect feature, draw line chart. I use microbit 1 and microbit 3 and OLED. And the main algorithm is draw line and change the data. I will talk them later. Now let me show you the briefly demonstration first. It is simple, right? But actually it is very difficult for us and costs us a lot of time. Since I could not find a function to draw an OLED straight line on the internet, so I was going to give up, but from the last lecture, I got some inspiration. So I decided to write a function by myself again. To draw a straight line from one point to another, we need to step the line up into a number of small vertical and horizontal lines, and then connect it one by one. Just like walking up a staircase, and when the steps are small enough, the staircase becomes a straight line. This is the main idea, and there are many more cases we need to consider. But I will not go into detail here. Let's directly go to the next code, change data. It is a function I wrote to change the number of heartbeats to coordinates in the OLED. Since most normal people's heartbeats are between 60 and 80, we make the y-axis non-equidistant so that the data between the 60 and 80 can display in a larger interval, while some data with small probability can be displayed in a small interval. As you can see, most the data between 60 and 80 can be displayed from 5 to 25, and other data will be displayed above 25 or below 5. Okay, this is my part. Thank you for your listening. If you have any question, please don't hesitate to connect me. Now, let's give the floor to Mr. Liu. Thank you.
Okay, thank you. Now let's move on to the part 3, database diagnose. So besides the other functions we have, another functions which is database diagnose is really necessary. Based on the range that the final data in, for example, between 100 to 84 or below 60 or between the 60 to 84, the product can analyze whether you have some potential to get disease or you are normal. And let's see the demonstration video. So first press the button, and on this OLED, it displays your heart condition is normal. And of course, we want to realize the commercialization of our product. So nowadays, people are not just want to know the heart rate, but instead, what they really want to know is the thing behind their heart rate, like potential heart disease. Second, most of the users are old, and we have old-friendly OLED screen with easy operation panel. Besides, users not only want the product to prevent them from potential disease, but also save their life when emergency happens. And that's why we have real-time anomaly monitoring and alarm. Last but not least, it should be portable. As you can see, we minimize the size into a ring. You can see this is the little sensor and the OLED screen. Below it, it is the microchip, which is the substitute of microbit. With all these functions, Our price is just 329 Hong Kong dollar. So in summary, our design is a portable heartbeat monitor with some functions which are not really complicated but necessary. Using our product, user can check their heart rate for plenty of purpose, whether just to check daily for heart disease prevention or monitor hospital patients or old patients at home. Most importantly, the price of it is really reasonable and affordable. And that's why we believe that it will be a successful product on the market. That's all for our presentation. Thank you for listening. If you have any question, please contact us.
When there is some strange data, the speaker will sound alarm, such as yeah. When I press both button A and button B, it will draw line. This is my average heart rate. Firstly, I press the button A and I want to retrieve some data. We have 24 data from which to which you want. I want 1 to 20, such as press the 1. This is tens. And this is ones. 22, yes. Okay, this is first feature, and the second feature, when I press button B, it will analyze my heart condition. My heart condition is normal, yeah.